Hello, and welcome to a digital lecture for Salt Lake Community College. This lecture will cover Section 4.1 for Introduction to Statistics, Examining Quantitative Data. There are a few definitions in this section that we would like to feel comfortable with. The first is the definition of a dot plot. A dot plot is the most basic of quantitative displays. It shows the values of the variable along a number line with duplicate values stacked. To create a dot plot of the following data, we would put a dot at each value along the number line. So 62, 64. Be consistent with the size of your dots, so don't put some dots really large. 59, 74, 68, 71, 69, 68. Notice that 68 is our first duplicate value, so we'll stack it above the previous 68. 63, 66, 64. Notice again that 64 is another duplicate value. 76, 66, again another duplicate value, we stacked above the previous 66. Your dot plot is a visual representation of your data, and it shows you the distribution of your data. The next idea we would like to be comfortable with is the mean. The mean is also referred to as the average, and it is a common way to measure the center of a distribution of quantitative data. There are two different types of means that we will discuss. The first is the sample mean, denoted as X bar. The sample mean of a quantitative variable is the sum of all the observations divided by the number of observations. So your sum, add up each of the values, and divide by the number of observed values. Let's look at a short example. To find your mean, we'll add up all of the values to find the sum. This is sometimes represented in sigma notation. This is a Greek letter, sigma. Sigma stands for find the sum of all of the values. So let's find the sum of 3, 5, 2, 6, and 3. Should be 19. Then n, the number of values. There was 5. So that x bar, our sample mean, is going to be the sum of all of our values divided by 5, which as a decimal, please confirm this, I think is about 3.8. When calculating your mean, there are a couple advantages and disadvantages that we should be aware of. First, one of the advantages. It is the most common measures of center that we discuss. It is best for theoretical results because there is a formula we can use to calculate it. And it uses all of the data that we have. Some of the disadvantages are it is affected by outliers, meaning it is not resistant. And it is not good for data with outliers or data that has skew. The second type of mean that we discuss is the population mean. The population mean of a quantitative variable is still the sum of all the values in your population divided by the number of individuals in the population. Here we use the Greek letter mu to represent our population mean. And it's again calculated by the sum of each of your values divided by the number of values that you added up, where capital N is the number of individuals in your population. Now, it's important to note that the sample mean, again referred to as x bar, is going to be a reasonable estimate for the population mean mu. That is, it provides a point estimate for the population mean. Recall previously that if we were talking about categorical data, then we use p hat as the point estimate for the population proportion. Another type of graphic that we would like to be comfortable with is the stem plot. This is another graph for quantitative data where the rightmost or last digit forms a leaf and the other digits form the stem. Let's look at an example of a stem and leaf plot with the following data. To create a stem and leaf plot, we would start by looking over our data and noticing what the leftmost digit is. The leftmost digits form the stem. So the stems that we are going to have, and we always want to write these in order without skipping any values, would be 5, 6, and 7. And then the leaves would be the rightmost digits. So 62 I could represent as a 2 in the leaf area. And so this represents 62. 64, 59, 74, 68, 71, 69, 68, and notice 68 is a duplicate value, but I still represent it with another 8. 63, 66, 64, 76, 66. When making your stem and leaf plot, we actually want to write our leaves in ascending order, not separated by any commas. So an actual stem and leaf plot would be rewritten as an ordered ascending value of the leaves, and it would look more like this. However, typically it's easier to create your stem and leaf plot by just writing out your values and then rewriting it in ascending order. The next idea we would like to discuss are bins and histograms. Bins are an interval of values for a quantitative variable. From these bins, we will create a histogram. And a histogram is a graph for quantitative data where bin counts are plotted as bars across an axis containing the values of the variable. To create a histogram of the following data, we would start by creating our bins. In this example, let's create bins of width 5. So our first bin would contain the values 55 to 59, 60 to 64, 65 to 69, 70 to 74, and then 75 to 79. And then we'll create a frequency distribution showing how many of the values fall within each bin. And then to create our histogram, we'll create bars that have equal width where the bars are touching. So a frequency histogram might look something like this. From your histogram, we can get an idea of data density. This is going to be a visual representation of how frequently the values of the variable occur. Higher bars represent data where there is more frequency. This about covers all the definitions for section 4.1. If you have further questions, be sure to review the example videos that follow or ask your instructor.